So in this video, we're going to extend onto what we call a frequency histogram. So if you recall, the data we're using is pulse rates of all students in a class. And I think we said there were like 12 and 12 is like 24 pulse rates. So there's 24 pieces of data here that we collected. So the first thing we did is we created an expanded frequency distribution. In doing so, the first thing we had to do is find this class width. Recall the class width was looking at the data. The largest piece of data was the 120. The smallest piece of data was this pulse rate of 65. And we had divided by the number of classes which was given to us. They wanted to divide it into 6 classes. Remember, when we have the number of classes, if we were creating our own, we have to choose between 5 and 20. But most of ours, they'll tell us what number of classes they want to break it into. And when we did this method, recall last time we got like 9.1 something, and we always want to round up to the next whole number, basically, the next usable number. So it's usually the next whole number. So as we move on down, we did all this already from last time, and we created, let's see. So we created our expanded frequency distribution thing. So what we want to do now is we want to construct a frequency histogram. A frequency histogram uses bars to represent the frequency distribution of the data set. So to construct the histogram, the first thing is we have to create the horizontal scale, which is going to be class boundaries. Class boundaries are a little bit different than class limits. Class limits is what we did in creating a frequency distribution table. When we create a histogram, we actually create what's called class boundaries. Class boundaries are similar to class limits, but the upper boundary will touch the adjacent lower boundary. There's not going to be any gaps between the graph. So as we do this, I'm going to go ahead and bring down our frequency distribution. And the first thing we want to do, like I said, is create this horizontal scale with the class boundaries. So in creating these class boundaries, we first have to identify the first lower boundary. The way it's done is we use the lower class limit and we subtract 0.5 or 5/10 from that. When creating the first upper boundary, we use the upper class limit and we add 0.5 to that. So remember, these were the class limits. So the first class limit was 65 to 74. So in creating the first lower boundary, the first lower class boundary, we have the 65 and we have to subtract 0.5 from that. So again, if you can do some math there, we would drop down to 64.5 there. So that's going to be our first lower class boundary. And to create our first upper class boundary, we have 74 as our boundary. And what we want to do is we want to add 0.5 to that. And that's going to give us then this 74.5. So this is going to help us start creating our horizontal scale. Is we're going to be using the 64.5 and the 74.5. So creating the rest of the boundaries, all we have to do is use the class width, and we add that to the lower and upper boundaries to create the rest of the class boundaries. So if you recall, our class widths, or our classes and class widths were given here. So to do our class boundaries, notice how we had this 64.5 is our new boundary, and 74.5 was our new upper boundary. And these are going to be what we call class boundaries. They're going to be used to create the horizontal scale on our graph. So I'm going to pause the video for a second and I'm going to complete the rest of these. So from there, I created the rest of my class boundaries by adding 10 to my class width. So 64.5 became 74.5, 84.5, 94.5, 104.5, and 114.5 by adding our class width, which was 10. So those are going to be our lower class boundaries. And then this is going to be our upper class boundaries, the 74.5, 84.5, 94.5, 104.5, and 114.5, and 124.5. Notice that the upper boundary and the lower boundary of the next adjacent one, they'll touch. So notice how this 84.5 is the upper boundary and it's going to be the new lower boundary. So the frequencies come from something we've already done in the original question. So if you recall way up here in our table, our expanded frequency table, our frequencies were already calculated for us. So we did those. So I already brought those down here, 4, 7, 4, 5, 3, 1. So those frequencies don't change. So to create a histogram, we are now going to be, this is going to be our horizontal scale, and the frequency is going to be our vertical scale. So notice how the number of times the pulse rate is, this is going to be our horizontal scale. We had that frequency. So like between 64.5 and 74.5 heartbeats, we had 4 people who had that range. 74.5 to 84.5, the frequency there was 7 people had heart rates in that range. 84.5 and 94.5, 4 people had a heart rate there. 94.5 to 104.5 is 5. 104.5 and 114.5 is 3. And 114.5 and 124.5 would be 1. Okay. So if you're going into nursing or if you just weren't interested in your own health, it would be a good idea, just to kind of look up what is a normal heart rate based on data. You could probably do a Google search on that and discover that what those actually are. My heart rate usually runs in the 90s. So I'm usually kind of in this 84.5 to 94.5 range. Mine usually is in this range here myself. So I've got that going on. So from here, I want to start creating the class boundaries. And what I'm going to do is I'm going to use, these are going to be my lower boundaries and these are going to be my upper boundaries. Remember, the upper boundary and lower boundary are going to be shared by the same tick mark. So I'm going to pause the video and I'm going to generate these tick marks here. So notice how my class boundaries, I had this 64.5 to 74.5. So that's how 64.5 to 74.5 is going to be my boundary. And then notice that when I move to my next spot here, I'll have the 74.8 to 84.5. So again, when we create these histograms, we're going to have these boxes or rectangles that are going to be constructed within these boundaries. So they're going to be constructed between these lower boundary and upper boundary. And the frequency is going to be how high up they go. So notice how I have this frequency of 4. So if I go from here, I got 1, 2, 3, 4. If I bring that over, I can kind of create then my box here. So I have my, if I draw a little box here, notice how this is not perfect, just kind of roughing it out. But that would be basically a 4 there for that frequency. So between 64.5 and 74.5, 4 people would have that rate, and I'm modeling it now within what's called a histogram. So 74.5 to 84.5, we had 7 heart rates there. So if I count up to 7, so I've got this 1, 2, 3, 4, 5, 6, 7. So I'll come across here. So again, I'm going to just kind of extend this up because I'm sharing the same boundary there. Go up to 7, come over, and then I'm going to just try to draw straight down to 84.5. So that would be my next rectangle. And we said that would be like 7 people that have that heart rate that are between 74.5 and 84.5. Then we had another 4, that's between 84.5 and 94.5. So we had another 4 there. So I'm going to bring that across here, 4, and bring it on down. So that's going to be that box, little rectangle. And then we have 94.5 to 104.5. I have a 5. So it's going to be up a little bit about there. So I'm going to extend this on up because I have to share that boundary. Come over and come down to 104.5. And again, I'm freehand this, so it makes it a little bit quicker than me trying to kind of make everything just perfect. And then we had this 104.5 to 114.5. That was 3. So I actually have to come down a little bit to 3. That would be about here. So I bring my bar over that way. Come on down. So that was a 3. And then last but not least, we had 114 to 124.5. We had this 14. I'm sorry, we had this 1. So we'd have this right here at 1. So I have a little bit of a bar or rectangle that extends up to there. So we can represent the data that way. So that would be representing a what's called a histogram, a frequency histogram. Notice also on the scale on my horizontal axis, I kind of got it broken because I really don't want to make an even, like on my frequency, these are all consistent, 1, 2, 3, but I'm kind of ignoring all the data until we get up to 64.5. So that broken means we're just going to start at this spot here instead of starting at 0. So that kind of helps us out a little bit as we move on. So that concludes creating what we call a frequency histogram.